When iron becomes an ion, it commonly occurs as either Fe2+ or Fe3+. This means that when these ions of iron bond to an anion, they will do so in different ratios, creating different compounds. In this lab, we are going to compare the reactions of two different iron chloride solutions, FeCl2 and FeCl3. Our goal for part 1 is to record observations of a reaction and determine which indicator produced the greatest color difference between two different iron solutions. As you can see here, in test tubes 1, 2, and 3, we've added FeCl2, or iron 2 chloride. In test tubes 4, 5, and 6, we've added FeCl3, or iron 3 chloride. Now we will add our first indicator, K4FeCN6, to both test tubes number 1 and number 4. Remember, test tube number 1 contains iron with a positive 2 charge, and test tube number 4 contains iron with a positive 3 charge. Be sure to record the colors of each reactant prior to mixing, and then the color of the product. Now we will add our second indicator, K3FeCN6. We will add it to test tubes 2 and 5. Remember, test tube number 2 contains iron with a positive 2 charge, and test tube 5 contains iron with a positive 3 charge. The last indicator we are going to test out is the KSCN, or potassium thiocyanate. We're going to add it to test tubes 3 and 6. Remember, test tube number 3 has iron with a positive 2 charge, and test tube number 6 has iron with a positive 3 charge. Sometimes in chemistry, if we're comparing solutions that are very dark in color, it helps to dilute each solution. So we're going to add enough water to each solution to dilute it so we can see the colors a little bit more vividly and compare them. Okay, now let's start comparing our solutions. What we are looking for is the indicator that produced the largest difference in color between the two iron compounds. Iron is a very important part of your diet, and it can be found in these two forms, Fe2+, which is called heme iron, and Fe3+, which is called non-heme iron. Now, heme iron is found in animal products, and it's more easily absorbed by the body. Non-heme iron is found in plant products, and it's less easily absorbed by the body. When we consume non-heme iron, it can interact with other chemicals and turn into heme iron. So in part 2 of this lab, we are going to start with non-heme iron, or iron with a positive 3 charge, and observe how it interacts with different chemicals that may be present in our bodies or the foods we eat. We will then be able to determine if the substance added was able to convert the non-heme iron, or Fe3+, into the heme iron, or Fe2+. Our indicator will be potassium thiocyanate. We will use this to test for the presence of heme iron. So say you're eating a bunch of vegetables that contain non-heme iron, or Fe3+, and you sprinkle some table salt on these vegetables. Does this table salt have the ability to convert non-heme iron into heme iron? Now let's observe what happens when those vegetables enter the stomach and interact with your stomach acid. Stomach acid consists primarily of hydrochloric acid. Will the acid be enough to convert non-heme iron, or Fe3+, into heme iron? Now let's see what happens if we put a little lemon juice on our vegetables. For the next test, I took a vitamin C capsule and ground it up. We're going to see the effect that vitamin C has on non-heme iron. So we saw the effect that vitamin C has on non-heme iron. But what if we were to consume our vegetables with a beverage that contained 100% of our daily value of vitamin C?